You've all tried that impossible task, rubbing your tummy while tapping your head. Why is that so difficult for our bimanual systems? What's going on there? I'd like to give you a different view than is typically thought. I'm going to tell you a little bit about bimanual conceptual constraints. I'm going to show you an example. So the example comes from research Franz and McCormick published in 2010. Well, think of it. Just try thinking of rubbing your tummy while patting your head. Phew. That dual task is difficult. It definitely results in interference in my hand actions, you might think. Well, using the domain of bimanual actions as an investigative tool, Franz and McCormick hypothesized that the way people think about the actions that they are to produce dictates whether or not forms of bimanual interference will actually occur. So the next slide will illustrate that basic type of task was used in that study. Can I get rid of that? So the basic task is here in this left panel. Look at these. These are congruent and these are incongruent. What it is this is sort of the display that you would use in a simple task like this, where on the desk you have these home keys that you're sitting very close to, and your left hand is sort of here by this home key, and the right hand is by this home key, and when you start the task, your hands are on those home keys. And then you get something like this. You either get targets like this, which are congruent, and they're congruent because they're the same distance away from the home keys, or they're incongruent, where this hand would have to go a long distance, whereas this one would have to go a short distance. Of course, these are just two examples. This scenario has 4 examples that you could make out of different positions of these targets. So the targets could be out here, or they could be one here and one there. But what's important here is that if we look at reaction time, the time from when these stimuli go up and when you start moving, the incongruent situation like this, when you're moving 2 different distances, results in a longer reaction time. So we're thinking about it more or planning more than in this condition here. And our question really is if we could sort of eliminate that effect of this being longer than this by having people focus on higher level constraints. So let's try a unified constraint. Let's connect these two with a little barbell in between them such that these 2 targets now actually look like one unified sort of a target. And let's do the same type of task. So when we do that sort of a task, we present the stimuli. You have a fixation point first that stays on for a little while, sort of an unpredictable amount of time, because we don't want people to predict what's going to happen. We then have some instructions that are encoded. And the instructions are in this form here, which is our second manipulation. It's a conceptual manipulation. Here, the instructions are in the form something like move both hands, reach with both hands, reach for both targets, move to both targets. Lots of different variations that always use the word both. And our idea here is that that is going to encourage a unified representation, or just as though you're doing just one task, you just happen to use 2 hands. We contrast that with a case in which there are separate trials. In this case, we use the word and. Move the left and the right hands, move the right and the left hands, move one hand and the other, and so forth and so on, where and is to indicate they're separate movement trials. Now we did all the appropriate controls where you make sure some of these instructions have the same number of words, have these instructions, and so forth, and so on, to be sure we don't have some other kind of problem going on there. The prediction is that when we use a perceptual manipulation like this, the incongruent reaction times are going to equal the congruent reaction times. In other words, people are going to conceptualize this as a single unified task that happens to use 2 hands. And that situation will differ from the baseline situation here, in which there are clearly 2 separate tasks because they're not unified. Similarly, the conceptual manipulation, The prediction is again that the incongruent reaction time will equal the congruent reaction time in the unified trials and not the separate trials by virtue of the pre-instruction display that we give on the screen, where both is unified and is separate. After those instructions are given and left on the screen for 2 seconds, giving people time to encode them and understand them, we present the targets. And the targets appear here on the desktop surface. They're projected from a projector above, and people then are to begin to move as soon as they can, and we look at reaction time, which is the time between from when those targets are presented to when a person begins to move. Well, what you can see here is that when we have separate instructions in the baseline case, we again get the effect that is a standard effect. The congruent trials are faster than the incongruent trials, and that's quite a large difference there. As you can see, what happens is when we use the perceptually unifying bar, those differences wash out completely. Now the congruent and the incongruent are about the same. So the reaction time for congruent and incongruent are pretty equal. Our conceptual manipulation of using those different language instructions also shows a similar effect. When we use the both condition, you can see here that the congruent and the incongruent are virtually the same. People unify those tasks, and that happens whether we use the perceptually separate conditions or we put a bar in to connect the 2 targets. So it seems that higher level constraints related to how we think about the tasks is what determines how we actually plan and execute the tasks. We think that high-level conceptual constraints result in the coupling of the 2 hands. We can think of the task as one unified task or as 2 separate tasks. Thinking of doing 2 things at once, like we did with rubbing the tummy and patting the head, results in interference between the tasks. There are 2 things we're planning, there are 2 things we're thinking about, and those things interfere. In contrast, thinking of doing just one unified task does not result in interference. For example, if I'm thinking of opening a jar, I'm certainly not thinking of my one hand holding the jar and my other hand moving in a direction that's opposite what the hand holding direction is. I'm thinking of one thing, opening a jar. It's a very high level unifying constraint. High level perceptual and conceptual representations override interference that otherwise would occur at low level sensory motor regions in the brain, just like an experienced pianist. When the person began to learn the task of playing the piano, the person was thinking about what the right hand needed to do in terms of the fingers hitting the keys and what the left hand needed to do. The person was thinking of the task at the lower level sensory motor representations. But once learned, the person is now thinking of the melody, or a person who's really good could think of improvising, maybe having even a complex melody going on. Those high-level constraints override the low-level sensory motor representations in the brain. And we think this is a general principle for how we learn. Thank you.